So we already saw how Kirchhoff's voltage law works on this circuit over here. So let's see how Kirchhoff's voltage law works on a current source. We have one here, but let's just first look at this very simple circuit so that we can understand the basics of how a current source works. So as I mentioned in the previous video, current sources are stubborn mofos, and they're going to push the current that they want across the circuit no matter what voltage source is trying very pathetically to push against it. So we know for sure, for a fact, that the current in this circuit, in this wire, is going to be equal to 1 amp. And I can prove that by showing you guys the simulation that was done by Multisim. So as you can see here, the current going through the circuit equals to 1 ampere. Doesn't matter that this is providing 20 volts. What's going to happen here is that this current source is going to provide 1 ampere to the circuit, and this voltage source has no other option but to absorb it, not to use another word. So if we use Kirchhoff's voltage law here, we know that the polarity that this has is this one, and then we know that the current goes in through positive, out through negative. That's my convention. And so we would do Kirchhoff's voltage law. We start here, go up, so we would have plus the voltage across the current source. And that's the only way that you can put a voltage across a current source in Kirchhoff's voltage law, because you do not have the current yet, and you do not have the resistance. Well, you have the current, but not the resistance. So you put it like that, and then you continue, and then you have from positive to negative, you have -3, 1 ampere, we already know that. And then we continue, and we have negative 20 volts equals to 0. So this would be voltage across the current source -3, because it's times 1 ampere, minus 20 equals to 0. This means that the voltage across the current source would be equal to 23 volts. And as we see here, the voltage across the current source equals to 23 volts. So how does this apply in bigger circuits when we're trying to do Kirchhoff's voltage law? My advice, because we do not know exactly what the resistance would be over here, and so we can't use Ohm's law, which is voltage equals current times resistance, I would advise you to skip in between like these that I don't know how to say in English, skip that part of the loop by any means that you can. So as you can see here, and I'm going to mark it in this color, in this loop, I actually skipped this current source. So I started from A, and I went over there, and then this is the loop that I used. And you can see that by this plus 2 times 2A, this one, and then we continue, and then we encounter this one, which is this one, and then we encounter this one, which is this part, and then we close the loop. Okay, so now let's show you with the next one, B. With B, I also tried to skip any current source by any means. So I went up, and then I went this way, and then I think I went this way. Let me see if that's correct. Yep, I went up, then I went this way, and then exactly I went down this way. So now with C, I went up this way, and then I went down this way, right? Yes, exactly, I did that. So as you can see, I went up through here, and then down through here. And then I closed the loop. So by any means, I just skipped these branches that have the current sources when I was using my loops.